Hi friends, good morning all of you. Examples on AC circuits. Let us continue today and try to do as many models as possible. Now yesterday we did with these RMS values, average values, finding those things. Even we have seen the case of superposition of AC signals with DC signal, finding the effective values. Now today let us go further regarding circuits containing inductors, capacitors and different models. Remember, models may be many, but what are those fundamental points to be remembered? Inductive reactance, how to write the magnitude. Capacitive reactance, how to write the magnitude. And then about impedance, how to write magnitude. If it is phase, how to find. Same those things. Now let us see this first example. Here I have shown an AC circuit with two inductors in parallel across a given AC source. One is 10 millihenry, the other one is 30 millihenry. Now, the simplest of the questions that can be asked is, if the current through 10 milliamp is, supposing it is 1.5 ampere, is said like that. If whenever we say current through, take it as instantaneous current only, right? Supposing if the current through 10 milliampere is 1.5 ampere, what will be the current through the other inductor? 30 millihenry is the question. Maybe the case of inductors, maybe AC, but the concept is the same. Parallel combination, current division, inverse ratio of resistance. That resistance here with respect to inductor is what called reactance. Therefore, here also the rule is the current through inductor I proportional to 1 by X I will write. X for the reactance term, right? Instead of resistance it is reactance in the case of inductor. I proportional to 1 by X, and we know that X is equal to omega times L. Omega times L, therefore, and the other result is X proportional to L. L for the inductance value, which is the given data. Therefore, now when we combine these two, what is the result you get? I1 upon I2 is L2 by L1, because when we combine these two results, the result is I proportional to 1 by L. Therefore, I1 by I2 is L2 by L1, and of course, the same point will be repeated, the meanings of I1 by I2. Whenever I am writing ratios like this for such examples, 1 I will take it for given values, 2 I will take it for the unknown, the required values. Therefore, now here I will write this I2 value is I2 value. 2 means here we need that 30 milliamp. And in this type of representations, 1 for the initial values, given values, 2 for unknown values or required values. The same case we will continue every time. Do remember. Therefore, now here I2, the required current is L1 upon L2 times I1 is the question. Of course, you will have the substitution L1, the first, not the first one. It is given, which is 10 by 30. So this is 1/3 of this 1.5. So this is 0.5 ampere. Such simple things. Here the rule is both current division and also looking to that given data, writing reactance, which reactance we have to write, like that. Now instead of, here I have given the case of two inductors parallel combination. Now you can extend this example in different ways. So with this simple example, now you will get the idea. We have given the case of two inductors parallel combination, right? Similarly, it can be the case of two capacitors in parallel combination, how to divide the currents. Then we know that same I proportional to 1 by X, X proportional to L in the case of inductor, whereas we know that X is equal to 1 by omega C. X is equal to 1 upon omega C, X proportional to 1 by C. X proportional to 1 by C, and therefore I proportional to C will be the result, such that I1 by I2 is equal to C1 by C2. See, now your ideas you can extend. We have given the devices series, parallel currents asked. The same it can also be the case of given devices, series combination, and of course since we know that in series combination it is the division of voltage, the potentials, it can be there also as well the same rule. Here the rule was I proportional to 1 by R, there the rule will be V proportional to capital R. Now let us do such examples also. Now you see in the next example what I did is, it is two different devices, inductor and as well as this one is 5 microfarad, which is capacitor. Inductor and capacitor in parallel across a given AC source. Remember, when you are looking at these two things, the most important point is what type of source you are using is very, very critical. Don't say that confusion this and all, because if it is a DC, it's completely different thing. For AC, we are now giving these solutions. Now supposing in this example, the simple question is that what is the current through, the ratio current through capacitor and current through inductor, what is this ratio is a simple question. And again the rule is same. What is that? I proportional to 1 by X for reactance, such that now we know that what is that I through capacitor, I through inductor is nothing but X L upon XC. Inverse ratio you see, IC by IL through inductor is XL times XC is the important thing. Therefore now we have to evaluate the XL values and XC values. Remember, XL by XC you can never write it as, supposing if I do it, you see, since I want only the ratio, what is that IC by IL, which is equal to this XL, which is omega times L, and this is 1 by omega times C. Therefore this IC by IL is omega square times L times C. L times C. Of course this omega square happens to be a constant. Therefore this IC by IL value will be equal to L times C. Now the values are given and that will give you the values. It can be asked simple ratios or one current given, the other current is asked. Now see, next example we will extend it a bit further. The question is bit extended. How? I said we have a bulb with rating 50 watt 100 volt bulb connected to 200 volt 50 hertz source, an AC source. Now the question is, what capacitor is essential in series with the lamp is the question. And similarly it can also be asked maybe what is the inductor required in series with the bulb. Where to begin, how to understand this question? Why we need this series resistor? Because you see the rating, a bulb has a voltage rating of 100 volts. Therefore the voltage across the bulb should not exceed 100 volts. Whereas the given source is of 200 volts. Therefore 100 volts is excess, and this excess voltage to be shared by some other device, and to share the voltage it should be the case of series combination. Is the concept clear? Now what is the excess voltage we are getting? 200 minus 100, 100 volts. So that 100 volts should be taken up by the capacitor is the first take. Therefore V across capacitor is equal to 100 volts. And since we know that V across R, bulb can be treated as a resistor, VR by VC. VR by VC, which is I times R by, I times XC. I times XC. So first let us calculate the value of XC. Therefore now XC is equal to how much? 1 upon omega, means 2 pi F. 2 pi F will give you 100 pi times, what is the capacity that is given? Yes, we need it. This is what is the value of XC. Now, first let us see, this XC should be equal to R. One more important point. Why? See, we are doing it in series. Only how many volts are taken by the bulb? 100. Therefore, to share the same voltage, the reactance of the capacitor should be same as resistance of the bulb. Why? Because now I am telling you V across R by V across C is equal to some ratio we are getting which is equal to 1 here, 100 by 100. And we know that this ratio VR by VC is equal to R by XC. This value is VR by VC is equal to R by XC, the ratio of voltages in the ratio of resistors. Therefore, this value of XC should be equal to R because in the given data, yes, this ratio is 1. Therefore, from this we can write it as XC is equal to R. And how to write the resistance of a bulb? We know that this is V squared by capital R, again V naught squared, the rated values. V naught squared by V naught squared by P, the resistance of a bulb is equal to 1 by 100 pi C. Now all the values are given. V naught is going to be 100 and power is going to be 50 watt. Therefore this 100 square, you will get it as 10 raised 4 and power P is yes 50. Therefore the value of C here. Now this will be like 2 times. So C value is 1 by this is 2 pi into 10 raised 4. Now the answer you will get it anyways. This is 10 raised minus 4, 1 by 2 pi value. 1 by 2 pi value means 1 by 6.28 into 10 raised minus 4. So this 1 by 6 value and then writing it in the correct submultiples, that is all. This particular question you will see it's a really lengthy question. To understand otherwise we are very good at our concept because there are 2 aspects. Voltage division is there, first point. Second point is that the concept of wattage and how to calculate the resistance of bulb. And then matching these voltages and finding the unknown values. In the NEET examinations or CET examinations, such cases are there. What I suggest you is that you don't try to do because it is almost taking like 1.5 minutes or 2 minutes for you in the examination. And that is why I try to skip them and go further. So that in the examination the key point is, yes, looking to all the 60 examples in 1 hour during CET and at the same time in the NEET exam also, all the 45 questions I need to look at. And all such cases, though it is easy time taking, therefore you can skip. And in your second round, if it is possible, since you have got the concept, you can go for the solution. That is how you manage your time, and which is very essential for our competitive examination. Easier examples requires only the good understanding of the concept. Again, I am telling you, only 5 to 10%, even not 10%, so 5% of the students, they will do examples in this particular topic, though it's very easy. That is why I go through your sessions of synapses one more time and make sure you have listed all those expressions in the sequence and how to find. Look at this example. Here shown 1, 2, 3 or 4 graphs, whichever number is shown, and said which of the following graphs represents the pure inductor circuit. So whenever we read the question, while reading the question itself, we should have some good intakes. The point is pure inductor circuit. What is the characteristic? Yes, because of inductive reactance, current lags voltage by pi by 2. What is the pi by 2 now here refers another important point. Whether it is inductor pure or pure capacitor circuits, phase difference is pi by 2 between voltage and current. What is the physical meaning of that? How we take that means? When we say they are in phase, voltage changes and current changes will be in proportion. Voltage 0, current 0. Voltage becomes maximum, current also becomes maximum at the same instant. Voltage reverses in direction, current also reverses in the direction. Same instant. Everything happening in proportion. Whereas phase difference, what does it mean? And especially now when we say pi by 2. In pure inductor circuit, current lags voltage by pi by 2. What does it mean? When voltage is maximum, current is 0. When voltage is maximum, current is 0 or vice versa. And also they won't reverse in their directions at the same instant also. That is how you will find. So that is why one has a sine function, the other one has cos function. And here identifying that sine and cos functions with increasing, lagging, that is what is leading or lagging identification is what is the matter here. Though it is a conceptual question, see, we should have a very thorough understanding of the concept. Here the first graph you will see where both curves, because here two curves are shown. One solid line which represents the voltage curve and the other one is a dotted line that represents a current signal, supposing it is set like that. So in all the 3 or 4 graphs we have two, dotted lines and solid lines graphs. In the first case what we find is that there is a phase, proportionate changes, 0, maximum, reversing, and then we have explained, therefore it cannot be a graph. It cannot be a graph. Now, look at this second example. Second graph, what you observe is that this, of course, dotted line is current. Watch it keenly. I don't know whether it is visible on the board or not. Watch it carefully. This dotted line is for current signal, right? This current signal and this solid line for voltage signal, what is that you observe? Here we observe that voltage, because this is negative scale, you see, negative scale of the graph. Therefore, what you observe is that voltage is lagging current. Voltage is lagging current, whereas we know that it is current lagging voltage is the case. Therefore, even B, it cannot be our answer. So that is how we eliminate. Or if you are very sure, you can directly look at that one graph where you find the phase difference. Look at this third one, where you have seen that. See, this solid line, this is where current is 0, but here you will see that voltage is maximum. And you will find that T by 4 difference, T by 4. Maximum to 0, 0 to maximum. What is the time interval? T by 4, right? So that nature or that is fitting with this third graph, that is the graph C. Therefore, our right graph is C. So this is how. So for a given graph, finding the nature of the circuit. Similarly, you will be given for this particular C, pure L, pure CR. Which of the graphs will represent the correct representation. Point I have told you that this value of phase difference is pi by 2 in the case of pure inductor and pure capacitor. Whereas if it is combination like LR, CR, or even for that matter LCR in other than resonance state, when we take this phi value will not be 0. Will not be pi by 2, it will have some value in between 0 and pi by 2. Now, next example, one more numerical type I will show you. Here, or else conceptually I will tell you. Here the figure says, question is there. The given figure shows two bulbs which are identical bulbs. B1 and B2 are identical bulbs. One connected, B1 connected in series with a capacitor of 500 microfarad and this B2 is connected in series with an inductor of 10 millihenry. This is connected to an AC source. The question is that which of the bulbs will have more brightness? So now comparison of brightness. Again, no question of any numericals and simplifications. The concepts of. Now, what is the principle for the bulb to glow brighter is the bulb which carries higher current, is it not? The bulb that carries higher current, because both are identical, therefore, whichever carries higher current will have more brightness is the case. Therefore, now I am writing you here, the brightness of the bulb I am comparing with I, the current. And I know that this current is inversely proportional to 1 by R, resistance, parallel division of current according to I proportional to 1 by R. And since here we are talking about AC and both happens to be capacitor and inductor, instead of resistance I will write it as 1 by X. The only possibility, only thing that is left over is Now compare. What is the value of XL? XL is equal to omega L 2 pi FL. F is going to be 50. Therefore, this is 100 pi into 10 into 10 raised minus 3. So this number 1, 2, 3 and this. So this is simply pi you will get, right? 1, 2, 3 zeros and 10 raised minus 3. Therefore, this is pi ohm. Reactance unit is same ohm. And now what is the value of XC? This is 1 upon omega is 100 pi. The C value given to be 500 micro. This is 100 pi. 500 into 10 raised minus 6. So that is 5 into 10 raised minus 4. So this all will give you as this is 10 raised minus 2. Therefore this is 10 raised minus 2. Therefore this is 10 square by 5 pi. 5 pi value is nearly 15, right? So this is nearly 100 by 15 times. You can become, you are taking the comparisons, not exact numbers. If it's 100 by 15 greater than pi. So our example and numericals will tell you that our result is in the given data, X L less than XC. XL less than XC, therefore current through inductor is greater than current through capacitor, and hence the point that what is IL? This one is inductor B2 bulb, therefore B2 bulb glows brighter than B. So the idea, last examples also we have divided current. This is also the same case of division of current. See, maybe it seems that we have done 3 or 4 different examples, but for all the principles, the concept is the same, current division. And in next example also we have seen series combination and then finding the values of C or L values like that. One more example. Feeling difficulty? If feeling difficulty, one more 5 minutes, just 5 minutes, go through your synapses, get acquaintance with all the terminology and all those definitions. Next example. Again see, next example, again a figure is given. And for this, the questions can be the simplest. In fact, that will be the case with your CET and NEET. Suppose here, this is a CR circuit that I have shown 200 ohm 50 head AC source. And this is say 100 ohms, suppose I don't mention anything here. 100 ohms resistor and capacity value is also given. Suppose it is some 20 microfarad, 500 microfarad, some numbers are given. Now you are asked to find, like phase difference, we know that phi is equal to tan inverse, yes, x by r, substitutions. Which x is there, whether xc or xr, like that. You can be asked with the phase difference, you can be also asked with the power factor, right? You can also be asked with what is the power factor of the circuit, so for the given data. Same question, but ask you like this. Supposing I say this is 200 volts, 50 Hz, and this carries a maximum current of 2 amperes. So peak current in the circuit is 2 ampere. 2 ampere is given data. Now the question says the power consumed in the circuit is 100 watt. Power consumption in the entire circuit is 100 watt. Find the value of C. Here C is the unknown thing. C is the unknown thing. So earlier I did it to minimize my time of video. We have done this example, you see. What is our definition of power in AC circuits? Power P is equal to V0 times I0 by 2 times cos phi. Shall I write it? Power, which is generally, whenever we write like this is what is average power consumed. Actually, in the data also, the term should be there, the average power consumed in the, because we take the complete cycle. But actually, that average term, even if it is not given, just we take it for granted that it is the average power. P average is equal to, yes, V0, the peak value, I0, the peak value upon 2. Times, yes, cos phi. This was the definition of power in AC circuits. Cos phi, the power factor, remember cos phi we got the number as, yes, R by Z. R by Z cos phi. Tan phi is equal to X by R. Tan phi is equal to R by Z. Results are there with you. That is what made use here. Now you see power 100 ohms, 100 watt is equal to 200 V0 value, because whenever you are given a data like this value refers to peak value, not RMS value. So this is 200 V0, and I0 is also a data, which is 2 by 2 times cos phi. This will show you that cos phi is equal to 1 by 2. What is the cos phi? Yes, cos phi value earlier I told you, cos phi is equal to R by Z. R by Z. Now since this is the case of CR circuit, that Z value is nothing but under root R square plus XC square. Z is root of R square plus X square. Therefore this R square plus XC square is what is cos phi. Since there is square that I have squared on both sides, therefore squaring on both sides will get R square by R square plus X square. Of course X for XC here is nothing but 1 by 4. This 1 by 4. Substitution will tell you that X value is root 3 times R. So the value of XC, this X refers to of course XC because of CR circuit, root 3 times R. Now again 1 by XC value 1 by omega C is equal to root 3 times R given in the data to be 100. So the calculation will show you this 10 rise minus 3 by 1 by pi root 3. Maybe options given in terms of pi is also possible. Otherwise, I am telling you, expecting that number, the estimation to one decimal is very important. Now I will do it quickly. If you can catch me, try that. 1 by root pi, pi value 3.141, you write, and root 3 value 1.73. So what I take 1.7 to 3.1, 1.7 to 3, even if you take 17 3s are 51. So this entire number will be 1 by 5.1. If 1 by 5.1 nearly gives you, if it is 1.5 it will be 0.2. Therefore if it is 1 by 5.1 it will be 1.19 will definitely get anyways. So 0.19 into 10, and this will number something like 19 into 10 raised minus 6. That minus 6 referring to micro. Therefore, my answer will be searching for the options nearer to that 19 number, whichever available, that will be my answer, right? So likewise, be with regular touch with my definitions, and then of course in NEET and CET making use of ABCD options, identifying that with estimation is another key point. Do find. Let us take all LCR series combination. Simplest example, when I say simplest, don't laugh at it. All examples are simplest only because we are using those 4 or 5 equations repeatedly as a single equation or 1 or 2 equations used one after the other. Here shows a simple example, and let us do different types of questioning for the same circuit. It is 250 volts, 50 Hz given to be the AC source, and all resistor, capacitor, inductor values are also given. Now for this data, asking for what is the reactance of the circuit, what is the impedance of the circuit, what is the phase difference case that arises, and what is the power factor of the circuit. So using all those simple formulae, direct substitution. Here L is there, therefore it is XL, omega times L. C is there, 1 by omega C becomes XC, right? Such that we'll compare what is the XC, whether greater or XL that is greater. That will tell you. Supposing, now let us verify such case here. What is that happening here? Now what is the omega L value? Sorry, XL value. XL value is 2 times, right? So this is 100 pi times 20 millihenry, right? So these many ohms, and what is the value of XC? XC 1 upon, yes, 100 pi going to be 500 microfarads, right? 500 into 10 raised minus 6, that all 5 into 10 raised minus 4. Again, look at these numbers. So this is the 10 raised minus 2, right? So this is 10 squared by 5 pi value we got, 10 squared by 5 pi value we got. 100 by 5 by 15 times you will get. Look at these numbers, what is that? You can look at this number, 1, 2, 3 and click on, therefore this value is 2 pi. 2 by, yes. Now, looking to these numbers, you can easily tell that XC is greater than XL in the given case. Since XC is greater than XL, this circuit will act as a capacitive circuit. That is, it acts as a CR circuit. If supposing I get XL greater than XC, then the circuit will act as LR circuit. Likewise, options can also be given. In this circuit, the options may be like the following: the above circuit acts as LR circuit or CR circuit or only L circuit or only pure R circuit. Examples are given. When do we get such cases? Comparison of XL and XC. XC greater than XL, CR. XL greater than XR, LR. XL is equal to XC, the case of pure resistor network. Likewise, is that okay? See, asking about the individual characteristics like phase difference, power factors, impedances, or apart from that, what is the nature of the circuit? Now, the same example, small changes let us do. Supposing this is, I said some good numbers, let it be easy. Suppose I make it as 200 ohms, 50 Hz. Now here it says 3 voltmeters are connected. 3 voltmeters are connected. Each across resistor V1, across capacitor V2 and across inductor, this is V3. Now the example says that the question, the data says V1 reads 100 ohms. 100 ohms. Or let me take some 150 volts. V1 150 volts and supposing V3 reading 50 volts to confuse us. V3 is equal to 50 volts. What is the reading of V2? In the given figure, V2 is the voltmeter across capacitor. Therefore, now we have to find V across C. Now, most of the cases, when it is CE and NEET, most of the cases you will be given such that XL is equal to XC. The numbers first. Whenever LCR is given, evaluate XL value and evaluate XC values. 99% of the examples you will find XL equal to XC. So XL is equal to XC will be the case of resonance, and therefore all those consequences of resonance we have detailed in the last sessions. That will be the answers. But now here, already we did one part. In the given example, what is that we have seen? We have seen XC is greater than XL. We have seen. Therefore, naturally VC is greater than VL. Is one important take. XL greater than XC. Therefore, VC greater than VL for the series combination. Now, what is the relation between different voltages that we have told? We have told E is equal to under root V square VR square plus VC difference VL. Here higher minus lower we will take whole square. Now here, since we know that VC is greater than VL, I will straight away write it as VC minus VL. Now I will take the square and remove this, so E squared is equal to substitution, get the answer, right? Shall I do? E squared 4 into 10 raised 4, V R square 15 square, it is 2.25 into 10 raised 4, 15 squared is 225, right? 2.25 into 10 raised 4 plus VC, we need that value. VC minus, the other example is going to be 50. So this is VC minus 50 whole square is the answer. Of course, one more line I will do. After that, I told you make use of your ABCD options. 4 minus 2.25, yes, it will be 1.75 times 10 raised 4 is equal to VC minus 50 whole square. Supposing taking again roots on both sides, what you get? Root 1.75, near value 169 you will get as 13, 169, 13. Therefore it's something like this, like 1.3, 1.32, whatever it is, 1.32 into 10 square is equal to VC minus 50. So this is 132. 132 plus 50, that is what is 182. That is what is the value of VC. So that is how it goes. Numbers, without doing calculation, most of the times your options will definitely help you. Please try to use your assignments in such a way that your calculations will be a bit easier in the examination hall.